1000 Inventions that changed the world. Aqueduct. Aqueducts are remarkable feats of engineering that have played a crucial role in the development of civilizations throughout history. These structures, designed to transport water over long distances from its source to areas in need, have provided essential water supply for cities, agriculture, and industrial activities, contributing to the growth and prosperity of societies around the world. The origins of aqueducts can be traced back to ancient civilizations such as the Mesopotamians, Egyptians, and the Indus Valley Civilization, who built rudimentary canal systems to irrigate crops and supply water to settlements. However, it was the ancient Romans who perfected the design and construction of aqueducts, creating some of the most impressive and enduring water supply systems in antiquity. The Roman aqueducts, built between the 4th century BCE and the 4th century CE, were marvels of engineering innovation and ingenuity. These massive stone structures consisted of a network of channels, tunnels, and arches that transported water from springs or rivers to cities, towns, and military outposts across the Roman Empire. One of the most famous Roman aqueducts is the Aqua Appia, constructed in 312 BCE, which supplied water to the city of Rome for over 4 centuries. The Aqua Claudia, built between 38 and 52 CE, was another remarkable aqueduct that brought water to Rome from sources over 68 kilometers away. These aqueducts relied on gravity to maintain a steady flow of water, with a slight downward slope ensuring that water flowed continuously from its source to its destination. The construction of Roman aqueducts required meticulous planning, surveying, and skilled craftsmanship. Engineers used advanced techniques such as cut-and-cover tunneling, inverted siphons, and arched bridges to overcome obstacles such as hills, valleys, and rivers. The use of durable materials such as stone, concrete, and brick ensured the longevity and stability of these structures, many of which remain standing to this day as testament to Roman engineering prowess. In addition to providing water for drinking, bathing, and sanitation, Roman aqueducts also supported a variety of industrial activities, such as milling, mining, and manufacturing. Water from aqueducts was channeled into public fountains, baths, and private villas, enhancing the quality of life for Roman citizens and contributing to the social and cultural life of the empire. After the fall of the Roman Empire, the knowledge and technology of aqueduct construction were largely lost in Europe, and many aqueducts fell into disrepair or were destroyed. However, the legacy of Roman aqueducts lived on in the collective memory of humanity, inspiring later generations of engineers and architects to build similar water supply systems in different parts of the world. In the Middle Ages, Islamic civilizations in the Middle East and Spain built their own aqueducts, known as qanats or acequias, to transport water for irrigation and urban water supply. These aqueducts featured underground tunnels and channels, sometimes spanning great distances across arid landscapes, and played a vital role in supporting agriculture and urbanization in regions with limited water resources. During the Renaissance and Enlightenment periods, European cities such as Paris, London, and Vienna constructed new aqueducts to meet the growing demand for water supply as populations increased and urbanization expanded. These aqueducts combined elements of Roman and medieval engineering techniques, incorporating arches, tunnels, and reservoirs to transport and store water. In the modern era, aqueducts continue to be built and maintained in many parts of the world to provide water for drinking, irrigation, and industrial purposes. While the technology and materials used in aqueduct construction have evolved over time, the fundamental principles of gravity-driven water transport remain unchanged, reflecting the enduring legacy of ancient civilizations and their remarkable achievements in engineering and infrastructure.